So yesterday we started talking about linear models and how we can sometimes use equations of lines to represent things in the real world. Today we're going to take that one step further. So not only are we going to have to write a linear model, we're also going to have to use it to predict a value in the real world. So let's take a look at our review. We know that a linear model looks like this. Y equals mx plus b. And in this model, the m is the slope, and the b is the y-intercept. Now, in a linear model, the slope is the number that repeats. We can look for the word per, as in per hour, per day, per year, to tell us that this number is repeating. In a linear model, the y-intercept is a one-time number. Sometimes we call this the starting amount. So it doesn't repeat. It's how much you start with or what your initial value would be. Now let's take a look at an example where we're going to have to create one of these models and use it to do other things. It says in number 1, a truck rental company rents a moving truck for one day by charging $29 plus 20 cents per mile. Write a linear model that represents the cost C in dollars of renting the truck to the number of X miles driven. And then for part A, find the cost of driving 110 miles. And for part B, if you had $300 to spend, how far could you drive? Well, let's start by writing a linear model. We're going to need an equation before we can do either of these things. It tells me that the cost is going to be C in dollars. And it tells me X is going to be the number of miles driven. And then I can go look for, in the equation, the number that repeats and the number that only occurs once, the starting amount. Because I'm going to be charged 20 cents per mile, this is going to be the number that repeats. And the $29 will be the starting amount, or the one-time fee. So if I write this equation, it's going to look like this. C equals 0.20 X plus 29. But I'm not done yet. After I write that equation, it says find the cost of driving 110 miles. Now 110 miles is going to be an X value because X represented the number of miles driven. So what I'm going to do is use this equation and I'm going to substitute the number 110 instead of X. So C will equal 0.20 times 110 plus 29. Now this is where having a calculator is going to be very handy. So if I type in 0.2 times 110 plus 29, I get 51. So my cost would be 51. And if I go back to what I said here, where cost is in dollars, I'm going to make sure that I put $51 in my final answer. Now in part B, we're going to be able to use this same equation, but sort of in a different way. So part B says, what if you only had $300 to spend? How far could you drive? Now $300 is a cost. So this is going to be the Y value instead of the X, which means because cost is C, instead of taking 300 and plugging it in for X, I'm going to plug it in for C. So I'm going to write 300 equals 0.20X plus 29. And then in order to figure out X, I'm going to have to solve this like an equation. So minus the 29 on both sides, which means I would get 271 equals 0.20X. And then I would divide by 0.20. And again, this is where a calculator is going to come in handy. And I get 1355. Now, X represented the number of miles. So I would write the word miles here because X was the number of miles. And that's my final answer. Okay, so now basically we're writing the equation, but then we have to do more with it as opposed to yesterday where you got to just stop after writing the equation. Let's take a look at number 2. A chemist's salary was $35,000 in 1985 and increased by $300 per year. Write a linear model that relates the salary S of the chemist to the number of years since 1985. So it says S is going to be the salary of the chemist, and that we don't have a variable, so I'm just going to use X for the number of years since 1985. Oops, 85. And then if we write an equation, we're going to have S equals, now the number that repeats here is $300 per year, times X is the number of years, plus the number that's a one-time thing would be the $35,000. It's the starting amount. Now, part A says, use that to estimate the salary in 1991. Now, number of years since 1985 is the X's, but 1991 wouldn't be the X. And the reason is because 1991 doesn't mean that it's been 1,991 years since 1985. It's actually only been 6 years, because to go from 1985 to 1991, X would just be 6 years. So what I'm going to do now is take the 6 and plug it into my equation. So 300 times 6, because 6 is an X, plus 35,000. Then I'm going to simplify. So 300 times 6 plus 35,000 would give me 36,800. And if I look at what S stands for, S is the salary. So I would put a dollar sign here for how much money the chemist is making. Now, part B says, if the chemist is making $38,000, estimate the year. Because this says $38,000, that's going to be a salary value. Because S stands for how much money he's making. So I'm going to replace the S, and I'm going to write 38,000 equals 300x plus 35,000. And then I'm going to solve. So I'm going to subtract 35,000 from both sides. And I'm going to get 3,000 equals 300x. Then I'm going to divide by 300. And I'm going to get 10 equals x. But that's not my final answer. X is the number of years since 1985. So if it says estimate the year, and I just say X is 10, then that's kind of like you saying that it's year 10, like 10 years after, BC. Now, what we really mean here is that it's been 10 years since 1985. So the year would equal 1985 plus 10, because it's been 10 years. Which means now it's going to be 1995. And that would be your final answer. Okay, let's try another one. So it says here, Commonwealth Edison supplies electricity to residential customers for a monthly customer charge of $7.58 plus $0.825 per kilowatt hour for up to 400 kilowatt hours. Write a linear model that relates the monthly charge C in dollars to the number of X kilowatt hours used in a month. So let's start by writing an equation, and then we're going to use it to find the monthly charge for 100 kilowatt hours and to know how much electricity we can use if we only have $25 to spend. So it says in the problem, C is going to be the monthly charge. X is going to be the number of kilowatt hours used. I'm going to abbreviate that KW-HR. And my equation would be C equals, now it says here I get charged this much per kilowatt hour, so that's going to be the repeating amount, X, plus the number that I use only one time would be $7.58. Now using that equation for part A, can we figure out the monthly charge for 100 kilowatt hours? Now 100 kilowatt hours is going to be an X value, because in this problem, X stands for the number of kilowatt hours. So what I'm going to do is take a 100 and plug it into my equation instead of X, because it's an X value. So C equals 0.8275 times 100 plus $7.58. So now let's see. 0.8275 times 100 plus $7.58, $90.33. And because C is measuring your charge per month, we're going to make sure to put a dollar sign here. Now, problem B says if you only have $25 to spend, how much can you use? So because $25 is a money amount, that's going to be a C value. Because in this problem, C stands for your monthly charge. So when I write this equation, I'm going to replace the C with a 25 equals 0.8275 X, 75, plus 758. Now if I subtract 758 from both sides, I get 25 minus 7.58 is 17.42. And then if I divide by 0.8275, X is going to equal 21.05. Now X is measured in kilowatt hours, so I'm going to make sure to put the label on here, KW-HR, to abbreviate kilowatt hours. Problem number 4 is sort of an SAT or PSAT example that aligns to this type of problem. So it says a babysitter charges $8 per hour for each babysitting job she works and charges a travel allowance of $10 for each job. Which of the following equations gives the number of hours H, the babysitter, worked at a job for which she charged $78? Well, let's start by writing an equation. She's going to charge $8 per hour plus $10 for travel. $8 is the number that repeats, which is why it's here, and $10 is the number she charges one time to travel, so that's why it's here. I'm using C to stand for charge and H to stand for hours, because it says in the problem H is the number of hours, and it just makes sense to me to use C for charge. Now it says she charged $78. So that means 78 becomes your C value. So which of these means the same thing as this? Well, if I read through these carefully, I notice all of the 78s are on the other side. So if I want to really make this equation match, I can just flip it around because an equal sign means we can write it either way. And then I notice it matches option C, which is what your correct answer choice would be. Problem number 5 says, Mr. Savage spent $45,000 to buy a new truck for his construction business. He estimated that the value of the truck decreases $1,500 per year. Determine after how many years the truck will be worth $27,000. So he says here he spent $45,000 to buy a new truck and that the value decreases by $1,500 per year. So what will it be worth? Well, I'm going to use V for value. So the value of the truck will be, he started with $45,000, so that's a one-time thing. And decreases means he's subtracting $1,500 per year. So this repeats. Now, because it's repeating by decreasing, I'm going to write negative $1,500 and then X plus he started with $4,500 or $45,000. Now it says how many years will the truck, after how many years will the truck be worth $27,000? So that's a value for the truck. So I'm going to replace the V with 27,000 equals negative 1,500x plus 45,000. And then I'm going to have to solve. So minus 45,000 from both sides. And I get negative 18,000. Then I'm going to have to divide by negative 1,500 and see what I get. So negative 18,000 divided by negative 1,500 gives me 12 years. So in 12 years, his truck is only going to be worth $27,000. So the option would be C. All right, guys, thank you so much for watching. I really appreciate it. I will see you guys tomorrow for some more practice with this whole linear modeling thing. Have a great afternoon.